This meeting is being recorded.
This last section from Chapter 10, 10.11, on radical polymerization, may be the one that you are most familiarized with, whether you know it or not, already, before I even introduce you. So this is the section that tells us about radical polymerization. So this monomer, if you recall what a polymer is, it's many monomers linked together in a chain, many small units. In this case, to make polyethylene, our polymer product, we would need ethylene here, our monomer. And we would link this together. In this case, polyethylene is formed through radical polymerization. And let's take a look at this process more specifically. So polymers, all different types of plastics, polyethylene specifically, surround us every day. And they commonly go through an initiation step with a peroxide here to generate, through homolytic bond cleavage, two alkoxy radicals. So that's what the RO radicals you see there are, through a thermolytic cleavage through heat in this case. Then we have our ethylene here, our two carbon pi bond that we see here, our two carbon alkene, and that radical peroxide will grab an electron from that pi bond, and we see our addition and movement of the other electron to the other side to form this new carbon radical. So we have our homolytic cleavage and then an addition, and now we have our new radical here. So what happens in the next step, in the propagation step here, is what we see down below. So we have our radical that was generated in the initiation step, and now we have another ethylene monomer here, and the same process happens again. And we see a longer chain now. So the pi bonds broke, and we added one monomer each time, each addition step. So we do that again here, another monomer, and so on and so on. So this radical chain continues along, and this is the net reaction here, the summation of the propagation steps. So overall, we'll have this polymer formation, and then eventually we will reach the termination stages. And with the polymer, it's no different. We can have our alkoxy, right, that radical from before, the alkoxy radical, couple with our polymer. So we would have a polymer, and then on the end, that alkoxy radical was added. Or we could have two polymer chains destroy each other, destroy the radical of each other, right, and create an even longer polymer chain, right? So this would continue on each way. So depending on what product is wanted or desired, we might want to end up with some chain branching. We can see that depending on conditions, we know that branching is an inevitable process, and it might occur through this type of mechanism where we see a hydrogen can be abstracted by a radical in this first step here. That generates this radical site for that ethylene pi bond to be broken, and then addition in this fashion, and then a new radical there. The branch continues. So whether or not we want a flexible plastic product like a squeeze bottle, you may want to have a highly branched polyethylene polymer, or if you want a more brittle or rigid, like a plastic bottle cap type plastic, then you would want that unbranched polyethylene polymer to form. So let's take a look at some other polymers that you may be familiar with. So we have our ethylene derivatives that can be used now. So now we have propylene. So this has an additional carbon in the carbon chain. So the polymer would form like so. So we have this extra methyl group where before we had only hydrogens. So that would be the difference. We have carpet fibers, some appliances, car tires, things of that nature can be from polypropylene polymers. Styrene, so this is a phenyl group, so you'd see that benzene ring coming off there wherever we see pH. This polystyrene polymer, this can be everything from televisions to radios to styrofoam. That can be polystyrene. Some other familiar polymers could be made from the monomer of vinyl chloride. So again, we have these substituted ethylene derivatives. So now we have chlorine that's added in our polymer chain, and we end up with polyvinyl chloride. This is things like PVC piping, if there are still CD cases out there, some garden hoses, raincoats, shower curtains. And then, of course, our tetrafluoro ethylene. So we have 4 fluorines added to our ethylene produces Teflon. So you're probably familiar with this trade name product. This is the non-stick coating on frying pans. So as I mentioned earlier on, you're probably more familiar with this section than others. To begin, we are actually going to look at a polymerization reaction in our last experiment, but we will not see the radical mechanism. We're actually going to be creating something called a polyamide. So we'll continue with the last slide and a reaction review in the next video.